Welcome to NucleCast, the official podcast of the NY Deterrence Center. Our host is Dr. Adam Lowther, co-founder and vice president for research at the National Institute for Deterrence Studies. The NY Deterrence Center is a 501c3 organization ensuring a broader understanding of the nation's strategic nuclear deterrent and its ongoing modernization. Thank you for listening and welcome to the show. The views of the host and the guests are their own.
Welcome back to another exciting episode of NucleCast. Of course, I'm your host, Adam Lowther, and today we've got a great guest. I'm talking about Dr. Byron Ristvet. Now, I'm sure many of you, because you're all nuclear enterprise folks, you know who Byron is. I mean, he is one of the great treasures of our enterprise. He's one of the graybeards. We'll post on our social media his full bio, so I'm not going to, go into it in great detail because that would take the entire show just to say everything Byron's done. But he's done a heck of a lot, and he knows a lot about nuclear weapons and a lot about nuclear testing. And he's, he spent years at DTRA and the labs and elsewhere. And so I'd asked Byron, I wanted him to come on. For one, we've never had Byron, so we wanted him to come on. And then we wanted to talk about nuclear testing, and we thought, what a great person to talk about that. So Byron, welcome to NucleCast. It's great to have you.
Thank you. So what do you want to ask?
So the president made an announcement that the United States here recently, the United States would test at the same levels of other nations, of our adversaries, and we would continue or restart nuclear testing, I should say. And, there's been a lot written about what that might look like, what that might mean. And I thought perhaps if you could sort of ground us with, just a basic understanding of nuclear testing, what types of nuclear testing are there, perhaps give us a brief history of nuclear testing, and then sort of help the audience and, those who might be listening who are perhaps less familiar with nuclear testing, help us sort of understand what the realm of testing might look like.
Well, first off, Adam, what's being done by our adversaries, and Russia a long time ago announced that they were doing what are called hydronuclear tests. And hydronuclear experiments, not tests. And a hydronuclear experiment is something where the absolute nuclear yield is less than the chemical or mechanical energy that you put in to cause nuclear reactions. And for example, that means maybe tens of kilograms of nuclear yield in addition to the high explosive or mechanical to cause the nuclear assembly to go together to cause fission. The Russians do this up at Novaya Zemlya, what is now called their central test site, used to be called the northern test site. Not a very nice place to work at. You're 73 degrees north. 200 days of the year, it does not get above freezing, okay? And but they're up there. They love it. I was invited to go up there. Never did. We did have one group go up there in 1991. We suspect the Chinese and the Pakistanis are also doing hydronuclear experiments, and which would be consistent with what we see in open source currently. So hydronukes only work well if you have a very strong nuclear test database. So if you want to do modifications to a nuclear weapon system, for example, change the type of explosive that causes the compression of the primary, you could probably feel very confident if you could get a few tens of kilograms of nuclear yield. And that gets you very high up on what's known as the alpha curve. That's the rate of fissioning, okay, the rate of neutron generation. And you actually measure that primarily by the gammas that are coming out. But at the same time, if you get up to 20 or 30 generations of fissioning, you're pretty sure it's going to work.
Right.
Okay. So that's the kind of experiments currently being done by the countries I named. Pakistan's probably, deficient because they've only really done 2 underground nuclear tests back in, 1988. And Pakistan is very clearly stated they won't test again until India tests, even though currently Russia, China, and Pakistan could test within months. And I'm talking less than 6 months. All of them are ready to go. And they publicly stated this. It's not classified. Yeah, the intelligence community monitors all this on a very regular basis, but you don't need to because they publicly state where they are. Anyway, we in the United States, if we were to resume testing, if we were just to go out and shake the ground, without diagnosing anything on the test, we could probably do it in about 6 to 9 months. If you wanted to do a normal diagnosed underground nuclear test, it would probably take us at least 3 years. And that's, trying to stay within, there's two different requirements that have been issued, not by the current president, but by the former president and way back under Bill Clinton. And that's PDD 15, Presidential Decision Directive 15. And then you have the National Security Memorandum 7 that Biden issued that basically say we need to be able to do a test within 36 months. Let me tell you, trying to get the requirements to do a test would probably take at least 36 months. Now, we used to do a study which ended in 2008 because that's when the funding for test readiness ceased. There's still no real funding for test readiness, where we would take the letters that are issued by the 3 laboratories, Sandia, Los Alamos, and Livermore, and also a very important letter, which is a statement of need from Stratcom, and see if we could meet the requirements issued in those nuclear weapons, U.S. nuclear weapons, that might require full-scale testing. And it was called the Test Scenarios Capability Analysis Review. And in 2008, we were told, stop writing that report because it's really bad. Okay? We can't meet that right now. We don't have the capability anymore. Yeah, we have 18 drill holes out at the Nevada test site. We have 1 operational tunnel out at the Nevada test site, the Nevada Nuclear Security Site under the current terminology, in which we could conduct a nuclear test. Big problem also is just the absolute lack of personnel who have ever done this. And I'm one of the few, and I'm approaching 80, and there aren't too many others around anymore. Yeah, you could pull a few out of retirement that still retain the capability to remember all the things. Now, I was a containment scientist, and that's making sure that they stay underground. I sat on the containment evaluation panel for a long time, and as a result, not only knew the things, because I was with the Defense Nuclear Agency in those days, of testing in tunnels for weapons effects. In case you don't know, there's really two types of nuclear testing we used to do. The laboratories did nuclear testing on the physics package. Now, I emphasize the physics package. We rarely tested a full-up nuclear weapon. We tested only the physics package. And the same way with Russia. They only tested their physics package. Take, for example, the B-61, a gravity bomb. Okay, the physics package has about maybe a couple of hundred components. There's 1,800 plus components in the actual weapon. Those are all designed by Sandia National Lab, okay, and manufactured at the Kansas City plant, okay. But we only test that. We did an occasional, most of the laboratory tests were what were called weapons development tests, okay. They'd get a statement of need from STRATCOM through the Nuclear Weapons Council, and then the labs would go and design a weapon to meet whatever those specifications were, okay, based on yield, based on weight, based on whatever, okay, and make that recommendation to the president, and the president would decide if you continue in that development. Now, we're in the process right now of redesigning a couple weapon systems. We've got the B-61 Mod 12 out there right now, which is more than just a life extension program. We're redesigning the W-80. It'll come out, that's the cruise missile warhead, which will come out as the W-80-4, based on subcritical experiments. And that's what the only thing we're doing out at the Nevada test site and other locations. Subcritical means, you're pushing plutonium, but at the same time, you're not having any yield. You don't have enough special nuclear material in these experiments. And what you're primarily looking at is the behavior of plutonium. And you think, gee, you built these nuclear weapons, you can just put them on the shelf and they'll be there forever. Well, that's not the case. Everything is aging. And so much in this country, because we're not making any new plutonium pits, okay? We expect to be producing 50 to 100 a year by this time, but Los Alamos is barely turning out one. They're currently down at Savannah River Nuclear Laboratory, gearing up to produce maybe 40 a year, 48 a year. And why do you worry about that? Plutonium decays. It decays and produces helium. And the helium doesn't outgas out of the plutonium. Instead, it collects in crystal defects. And the crystal defects keep this helium, because it starts off as helium-3, but it comes to be helium-4 very quickly. And the question is the accumulation of that going to affect the mechanical behavior of the plutonium? Okay, our devices are so sensitive, and we don't have a lot of extra yield to make sure that we'll drive a secondary to get full yield out of a nuclear device. The other things we were concerned with is the current production of the pits of the plutonium, the primaries, is no longer done at Rocky Flats. That closed down in 1988 over environmental concerns, which ended up not to be environmental concerns. You know, it's amazing. The FBI raided the facility, took 72 boxes of information from the files, and found there was absolutely no criminal violations of the current regulations at that time and laws, environmental. But, you know, to respond.
Let me stop you there because the topic of Rocky Flats is one we've never discussed on NucleCast. And all I've ever been told, because as a guy who's lived in Colorado, is that Rocky Flats was a disaster and the FBI raided it. And thank God it was shut down and it was a super fun cleanup site. And so are you telling me that all of that was not necessarily true?
Absolutely. And what's amazing is when the FBI went out to raid Rocky Flats, and this is from a colleague of mine. Unfortunately, he's not alive anymore. But anyway, he was the acting manager up at Rocky Flats when the FBI raid occurred. And it was to be an unannounced raid. And fortunately, an assistant U.S. attorney suddenly realized, hey, Rocky Flats is guarded by a guard force who are special deputy United States Marshals with full authority to shoot to kill. And so he called up this individual, who I will not name, and said, hey, they're on their way. And he immediately got on his radio and jumped in his car and said, let him in, don't shoot him. Okay, because they were going to ram the gates. And
wow.
Yeah, and the other interesting thing is, there was an amount of plutonium that was quote unquote missing from Rocky Flats. And they attributed it to basically mass weighing problems, okay? And when they started disassembling Rocky Flats, they found all of that missing plutonium and more within the ventilation system, which required them to fully change how they were dismantling them and not use any water to cause criticality problems.
Oh, wow.
And that's all unclassified. That's all out in reports that the public can read if they want to. I think they're mostly up at the Oak Ridge Scientific Technical Information Center. But anyway, that was what it was at Rocky Flats. No, there was no environmental problems there, other than in the early days of Rocky Flats. Rocky Flats opened up in 1956. Was the disposal of solvents.
Right.
Acetone and alcohol primarily is what you use to clean things. And they were poured into shallow trenches, clay-lined shallow trenches, which was acceptable at the time, fully within environmental regulations. That's a problem on a lot of facilities, both commercial and government nuclear facilities, government facilities that made jet engines, government facilities that did all that. All of those are in the process of being cleaned up. Rocky Flats never needed to be a Superfund site. In fact, it never was a Superfund site. It was a RCRA site. Okay, and RCRA is far different than Superfund in that RCRA just means it's overseen by the government and doesn't involve public oversight. And again, Rocky Flats is totally cleaned up. They cleaned up all those disposals for the chemicals that were used, and they're buried in, I think, in Nevada, at Beatty, Nevada. And, it's now an environmental research park.
Yeah. Okay.
And eventually, I'm sure it's going to be turned over and become part of the Denver expanding complex, residential complex, and they'll be building houses there someday.
Now, unfortunately, I took you
and
on
my
a bit
son
of
lives in Boulder, so I don't worry about it.
Now, I took you on a bit of a rabbit trail there, but I want to take a quick break. And then when we come back, I took you on a rabbit trail, and I'll let you get back to, in the direction you were going. But I'll take a quick break first. You're listening to NucleCast, and we'll be right back.
Join the ANWA Deterrence Center and NucleCast at the annual Nuclear Deterrence Summit, January 26th through 28th at the Crystal Marriott in Arlington, Virginia. This premier event brings together decision makers from government, national laboratories, and industry for strategic updates, high-value networking, and practical conversations that drive partnerships and business. Sign up through the link on our website to receive a 15% discount at anwadeter.org. We hope to see you there.
And we're back, and we're talking to Byron Ristvet. Of course, Byron is one of the nation's great graybeards in the nuclear enterprise. Now, we were talking about Rocky Flats before the break, but you were going in a different direction before I took you off that path. So I'll let you go back to talking about testing.
Well, first off, like I was saying earlier, there are two types of testing that was done out at the Nevada test site. One was, what the development of new physics packages, new nuclear weapons. That was done by Livermore and Los Alamos, the two design labs, with support from Sandia, who basically did all the non-nuclear weapons development. There was also weapons effects testing that was primarily done by the Department of Defense, the Defense Nuclear Agency, and its predecessors. And that's to ensure the survivability, vulnerability of our nuclear warheads. Okay. So they were, the Department of Defense could not conduct an underground nuclear test. That's prohibited by the Atomic Energy Act of 1954, has been amended so many times. Only the national labs, the Department of Energy, the National Nuclear Security Agency can conduct a nuclear experiment. So we would use a nuclear device provided by one of the nuclear labs to expose military hardware to the effects of radiation primarily, or in some cases we did tests that involved pre-mined nuclear cavities as big as 75 feet across to look at air blast, to look at thermal, to look at, various things. Most of those tests were done to validate codes, okay, to make sure that we were calculating those nuclear weapons effects correctly. Now, in the case of the exoatmospheric simulation tests, which were the bulk of those tests, we were making sure that our warheads would survive the nuclear battlefield and operate in the nuclear battlefield, i.e., they're flying through space. You set off a nuclear weapon somewhere nearby your adversary. Is it going to survive being attacked by the X-rays and the neutrons, and still be able to go to target and operate. So let me tell you, in that testing period, as I and others have testified in front of congressional committees, you weren't always, we were surprised on almost every weapon system we tested. The only one that didn't have a surprise, and those surprises, when I say that, means they would not have operated in the nuclear battlefield. They would have been compromised before they would get to target. And that was almost every strategic system until we got to the Trident II. Okay, the D5 of the Navy. That one sailed through those tests, even though we had a minor upset that didn't require additional testing. The labs, which is the vast majority of testing, were primarily testing nuclear devices. And I say nuclear devices because this is just the physics package of the nuclear weapon to see if it would perform. Okay. And again, nuclear weapons are, and in the originals were all done by basically analytical techniques, and then we moved to computers. And today, with 3D simulations of nuclear weapons, even though I'm an experimentalist, you start to believe that, yeah, we probably could design one without testing it. But that's because we have 1,024 U.S. nuclear tests, so we have this strong database to compare things to. That's the advantage of hydronuclear tests. You have to have a strong database to compare what your experiments are telling you. We also did very few physics phenomenology tests where we looked at new concepts to make sure an adversary might get a jump on us. We also did a very, very few stockpile confidence tests. This is where you pull a nuclear device out of the stockpile. Okay, not necessarily the full-up system, but at least the nuclear device, usually the full-up system. And you only modify the fire set so that you can fire it underground. Okay? And let me tell you, the pucker factor was huge whenever you did one of those, because, I actually was at one that didn't go off, which was a stockpile confidence test. It turned out it had nothing to do with the nuclear device, but it had to do when it was being assembled for testing underground, and it was not assembled properly. And so I will tell you, the Stratcom, the two Stratcom officers who were present for that test really got excited when it didn't go off. So it also proved that weapon system was 1 point safe. Okay, yeah. Which is always a huge thing. We also did a fair number of safety tests. We currently operate under the thing that all our weapon systems have to be safe to 1 in 100 million under normal conditions, 1 to 1 million under adverse conditions, i.e. being involved in a fuel fire or something like that. And so we did a very large number of safety tests to ensure that our nuclear weapon would achieve no more than 4 pounds of nuclear yield. Incidentally, right. The Soviet criteria is 5 tons. Wow. That's why they've never, quote unquote, had an accident, even though they have, and they've publicly told me that. Okay.
Yeah. That's interesting.
And I don't know what the Chinese safety criteria is. I don't know what, India or Pakistan is. But ours and the Brits and the French is 4 pounds. And so anyway, we've had broken arrows, and we've had bent spears and dull swords. They've all been recently made declassified and all made public. There's a book out that's goes through the broken arrows, goes through the dull swords, all of that if you want to read them. And it came out of a classified publication that was declassified about 2 or 3 years ago. We're very open about our weapons program. And, during the 90s and till about 2012, the Russians were very open about their programs too. And you can go out and read them in the press. I remember being part of a program where we paid the Russians to talk about their testing program. It's 3 volumes. Unfortunately, it has to be classified because it tells you how to build nuclear weapons.
We're unfortunately out of time. As we kind of wrap up our discussion right now, I just wanted to ask, is there something you really want the American people and our listeners to walk away understanding?
Well, currently, I think our stockpile is very reliable and safe. However, it's aging, and there's only a certain amount you can do computationally to ensure everything's going to operate fine. I think if this country could do hydronuclear experiments out at the Nevada test site, the Nevada National Security Site, it would give us great confidence that our stockpile would work. And because the minute you start questioning the reliability of your nuclear deterrents, and that's not just the warheads, that includes the systems that would deliver it, that's when your adversaries might take advantage of you. And so, the reason we do these experiments and evaluations is to ensure that things would work. Even when we tested, for example, in the effects tests that we did in the tunnels that the Department of Defense did, we would make sure our adversaries saw what we tested by leaving them outside of the portal, because we did those in tunnels, so that there was at least 1 to 2 satellite passes that would see what we were testing. And they would have to assume those tests were successful. And that's what deterrence is all about, making sure your adversary knows you have the capability to operate in the nuclear battlefield.
All right. Byron Ristvet, we'll leave it. We'll have the last word be that. Thanks for joining us on this episode of NucleCast.
My pleasure.
And we'll hang in there, guys, because we're going to have Byron back. There was so much more. That's the great thing about our history series, where we get to talk with folks like Byron and others who know so much and remember so much. And it's part of the reason it's so important for us to capture their experience and their legacy. So we'll look forward to having Byron back. And of course, thanks for joining us on this episode of NucleCast.
This has been a production of the ANWA Deterrence Center, a 501c3 that seeks to educate key decision makers, stakeholders, and the public to ensure a broader understanding of the nation's strategic nuclear deterrent. Our executive producer is Kimberly Charrington, and this episode has been engineered and mixed by David Krumthal. Help us grow our followers by sharing it and follow the show on LinkedIn, Facebook, and Twitter at NucleCast.